Hello everyone. Today we'll be exploring the new AI feature of this Google Colab, which is this Generative AI. Now I hope everyone must have used the Google Colab. Now if you have a very low specification in your laptops, it is a very good platform. Reason being, it provides you with a 12 GB of RAM along with 100 GB of data storage unit. So obviously to process any kind of data, because we know that when we talk about Python or Pandas data frame, the data has been transformed and data has been utilized from the in-memory consumption. It consumes your primary memory to process the data, and that is why it is very fast to perform any kind of operation. Now let's get started with the topic of today, which is the generative AI code. Now, when we traditionally talk about a data science project, any kind of data science project, we have to write a lot of code, right? Now, we always think like, okay, that we have learned a proper maths. We have learned well math about how the models work, which all processes we need to perform. Everything we have learned it. But performing that coding part is again a difficult part sometimes, because doing a lot of coding to and fro will takes a lot of time. And that is where you can see a generator AI code, or the new feature has been added to this Colab notebook. So let's get started and let's see. So when we write a traditional code, that's how we do it. So first we need to import all the libraries. So import pandas as PD. Then you might like to import numpy maybe as numpy np. And similarly, if you want to create a data frame, again you have to write a code such as data frame is equal to pd dot data frame, and then you have to think of what could be the possible values I should fill up. So it is a kind of a headache and also spends a lot of time. It also consumes a lot of time. So that is where you can use, or you can take the help of the generative code. Let's use this. Now, if you see in this line, you can see a generator, generate the code with AI or generate an AI code. So here it is very much like the prompt engineering, which you must have seen, or using the Bard or ChatGPT itself. So what is the benefit over here is that, let's say if I say import all the required libraries for classification project. Let's run it. So you can see, based on the prompt which we have provided, it have generated a code. Now let's go through it. So it imported a numpy, pandas, matplotlib and seaborn. So to manage the data first, then to perform the EDA, then we are doing the model selection, which is used for testing training split. Then it is performing the standard scaler, which is helping you to perform feature engineering. And then it is performing the logistic regression, which is a classification model. And after that, obviously, we need to perform some evaluation also. So for that, it imported evaluation metrics such as accuracy score, confusion metrics, and classification report. Pretty good, right? So it have complete and covered up almost all the possible requirements of libraries based on the classification project we have provided. But you might ask that what is the benefit then? You can get the code from the ChatGPT also. Now let's get started and let's see how it has been more beneficial rather than the regular ChatGPT or Bard AI. Now let's see, there's a question also given. Let's see that. Now that is the generative code assistance, which has been provided by the Google itself, that they are generating the code with the help of AI extensions. Now, if a code will be generated from any reference, it will be also providing you with the citations, like what is the reference place for this, but they will try to generate a new code always. So that will not be something which is a replication, which is a duplicacy from other place. But they have also given some warnings over here that the code generated might not be completely correct. We need to go through it once at least. Before executing, we need to go through it once again. So here we can see, so that is what has been mentioned over here. So let's come back. Now let's see how fast we can complete a project with the help of this AI part. Now when we talk about a project, when we talk about any project, there are few set of instructions or few set of steps we always perform. Now, when we talk about data science project, it consists of at least these steps, and the framework which we are going to discuss today is CRISP-DM. Now, what does that say? So, any problem statement starts with a business understanding. From business understanding, what does that mean? That you are understanding what is the business problem you are trying to fix. How we can fix this business problem. What are the possibilities? What are the rules and restrictions? What are the constraints available for that business problem? That is what we refer to as business understanding. Then we go to the next step of data understanding. Data understanding. Now, what does that step means? That after understanding the business problem, now what kind of data that particular company is providing you, that particular organization is providing you, what is the data, how it can solve the business problem, what are the possible ways of solving that business problem, or whether the data which we got from the company, is it sufficient or not. So this is something we include in this data understanding. And how we can possibly do it? So we check out for the data collection part, that whether the data is sufficient or not, or can we move forward. Then we perform some EDA. So obviously that collection part or requirement of data will be understood after doing the EDA part. Then we generate some sort of hypothesis that whether the data which we are going to work with, what are the possible ways of fixing that business problem with respect to this data available. That is what we refer to as hypothesis. So to reach a particular point, there can be n number of multiple ways to reach that point. That is what we refer to as hypothesis part. Then after performing that data understanding, we move to the next step, which includes data processing. Now, data processing includes cleaning of data. It includes EDA again, that after performing the cleaning, how well the data is. Then we finally go into the part of feature engineering and selection. Feature engineering and selection. So that is how the data processing is always been introduced and completed. After going with all of it, that's when we finally move to the modeling section. That is, we finally enter into the modeling part. Now here we also perform test train split for any kind of splitting matrix. Train test split. Then we apply multiple models for that particular business problem or for that particular scenario. Then we perform hyperparameter tuning to make it more advanced or make it more better. After performing the hyperparameter tuning, now you have the best possible model. Now finally we perform every kind of possible evaluation to see what are the pros and cons of going with that particular model. So that is what we have as the evaluation stage. And that is when the final project is been completed. So those evaluation reports have been shown to the business again. If they agree, that is when it is considered that your project is going for the final deployment stage. That is where your complete project lifecycle completes. And that is how each and every project management and the steps we perform in the case of this data science project. Now let's come back to the coding part. Let's see how this Generate AI part can help us do all the steps in the minimal of time. Now let's get started. Now let's go to the UCL repository. Now you must be knowing about this repository. Now the benefit of using this particular repository is that you're getting a raw data. The data which you're going to get from this particular website is going to be raw. You'll not get a code along with it. You'll not get any kind of ways to complete it or fix it. So you just get the data only. It's a data repository where you have only the data available. Now if we go with this one, okay, let's go with this one. It is having a decent size of data. So we have 48,842 values available. It's a multivariate data, which means we have multiple features depending on a single classification. So we have a classification data which is having categorical and integer data type values. Now the scenario over here is that we have to predict whether the income exceeds 50,000 a year based on the census data. So this is the census data we are having. Now these are the details of the columns which you can see right now. Next. So they are like 16 columns, 14 columns over here. And the final class label is like this: greater than 50K and less than 50K. Now let's get started. Now they do have given some baseline accuracies. Let's see how well it will work. Now you can get this data by using this import statement, or you can simply download it. So you can simply download this. I've already downloaded it, so I'll just directly load it over here. So to load any kind of data frame or data set, you can either connect your Google Drive, or you can directly upload a data set. Let's go for this adult data set. Now it is giving a warning because till the time you are using this particular session, it is active. Till the time you left it for a while, the session will end. And all the progress, all the data which you have loaded over here will automatically be removed. That was what the warning was. Now let's get started. Let's load this data. Now let's use the help of this Generative AI only to see how well we can do it. So the data has been loaded. Let's just copy the path. Create data frame. Create data frame using path this. So you can see the data frame has been created. Let's see. Let's run it. So it executed successfully. Show top 10 rows. Let's see. So df.head is the command it is showing you. Okay, so obviously there is some problem. We do not have any headers, so we need to provide it. So create a data frame using path this. You can pass a prompt as data frame doesn't have headers, and yeah, let's go with this. So you can see an argument has been added. Let's see. So we need to add some values also. Let's see how it can, if it can get the feature or not. So what we can do is to put on the names, like what are the possible names it can add over here. What we can possibly do is, let's take the help. Let's see if it can generate some headers also. Use it over here. Suggest some headers or column names. Let's say column names. Suggest some column names for the data set. Even though we know about the data set or the column names, let's use the help of this. Let's see what it will generate. It has successfully generated the column names. Let's just re-verify, or let's just simply run it. So if you again just run this one, so you can see all the column names has been added. And even if let's start with that is what we have as the data part. We have already understood the business problem that we have to predict based on the features which has been provided. Is the person or is that individual income is higher than 50K or less than 50K? That is what the business problem we have. And in this one, we got the data set now. Now let's get started with the basic EDA part. Let's see. Now here, if we check out, so it is showing you that it has some missing values. Okay, so let's start with some basic cleaning also. So if we check out over here, because there is a description already given, and that is the benefit of using the metadata, is that you get the description and you can read about it, that what are the possible scenarios with this. So if we see, there is no such values available, as there is no null value. But here it have mentioned that in occupation and in work class, we do have some missing values. And also here in the native country also. Now let's see how we can use this information. So check for null values. Now you do not have to specify what is the data frame you have, what is the kind of column or features do you have. It will automatically generate the column based on the data it is working with. So you can see there is no such null values. It is showing up right now, but obviously it have mentioned that there is some null values. So let's see. All unique values in all categorical feature. It already created a code which will search out for all the unique values in a particular column. So here we can see there is a part available which is question mark. Now let's see. Now let's add it over here in this particular prompt. It does not have headers and have some null values mentioned as this. Now let's see. So you can see it generated a full-fledged code. Now let's run this data frame. We got some error because as it already given you explanation that it can have some errors in the data frame or in the code itself. Now if we check it out, we got this, and if we check out for null values, so you can see it, we are able to identify the null values with respect to this. Now let's fix them. Now what are the possible ways you can fix these null values? So we can either replace them by the mode values of the column or by any particular value, or we can simply remove them also. That's up to us. So remove all the null values from dataset. Let's go with that. All rows from dataset. Let's go with this. So you just have to provide the prompt and it will keep on generating the code. Now let's start with the EDA process. Some basic cleaning has been done. Let's see how well it can perform the EDA. Now let's generate the code for that. Perform EDA methods on dataset. Let's see what all EDA method it's going to suggest. So it have generated a lot of one. Let's see, let's run of them. We have to run them individually because it will not be able to generate all of it at one go. So what we can possibly do is we can just simply copy paste this. Like if you just go like this, run it. So you got the counter plot for the income. Then you can go with value counts to verify the values again. You can get the same using the pie plot also, pie chart or pie plot, the same values. Here we have is group by data. Let's use this, which is what it is showing you. So it provided with some bivariate analysis. So these are two individual values only. So that is the pivot table we got for this particular data set, that for the race and income, how the values have been distinguished. Then another group by. So there are multiple group by statement it created. Now let's use some EDA part. Create some visualization for this data frame, data set. Now you can see the additional benefit which you're getting is you don't have to specify which columns you have to use or how they have been different. Here it can automatically detect everything. Visualization for this data set using Seaborn, suppose. Now it is used it. It is using the value pie plot. So it is generating the pie plot for this. So this way we are able to do multiple data analysis, a lot of different types of analysis based on multiple different columns. If you see education and income, occupation, then native country, marital status, work class, and many other columns. So it has been doing bivariate analysis. Let's use one more, which is multivariate analysis. Let's see what it will come up with. Okay, so correlation plot is also multivariate analysis. Let's say instead of correlation plot, what else it can perform except code. So it did some group by clause for multiple columns. So you can see it has been grouping the data for each and every column along with the count. So that is how it is doing some lot of group by, a lot of different kind of EDA you can perform. So after performing the basic EDA, let's go see how well it can perform the feature engineering part. Now first, because we have multiple columns and a categorical feature, let's generate a code which can perform encoding on top of it. So let's see how we can do it. Encode the categorical feature. And keep each encoder separate so that it can be reused. So what we are saying here, that for each individual categorical column, create an individual encoder. Let's see. So what it have done over here. So for label encoder, it is filling up first. So it is just keeping it additional check that if there is any kind of null value, fill it with the unknown value. If there is any null values, fill it with the unknown value. Then it created multiple encoders and now it is encoding all of the columns. And work class, education, medical status, occupation, this and okay, we need to add income also. Let's create an income column also over here because we have an income also as a categorical feature. So that is what I said earlier, that we need to re-verify things. We cannot simply just directly rely on this one. Simply replace it. Let's run it. Okay, that is 6. Okay, I also need to change it. Let's get started. Okay, so the encoding has been done. So we have performed the feature engineering in a very good, easy to go with method. Now let's recheck the data set. df.head. So you can see we are left with one column as relationship. So let's do it for that also. So we can see all the columns has been encoded. So let's move further. Now here we can see different scales of feature. We have different scales of feature. One is in hundreds, one is in thousands. Another one is in numerics only. So let's convert this also. So let's perform the feature scaling. Perform feature scaling. On data set. So it automatically performed the standard scaler on all the numeric features only. So let's see if we are missing on any of them. So let's just simply run it. So that has been already been fixed. Now what we have to do is we have to split the data set into testing training. So perform test train split on data set with suppose 80-20 ratio. With 80-20 ratio. So it performed that testing size is 0.2 with the random seed is 42. Let's run this. That's already been done now. Now let's perform the multiple classification models. We are not going to apply a single model. We'll be applying multiple classification models. So let's say perform let's on the prompt part. Perform multiple classification models on data. Let's see. So it is performing. Okay, so these are the list of models such as random forest, SVM, logistic regression, decision tree, k nearest neighbors, and Gaussian naive Bayes. It is applying all these models and giving you the reports of each one of them. Let's see. When we are applying all these models, so that is the first one, that is for random forest. Then we'll get it for the SVM or SVC or SVM. Now it can take few minutes. For all the remaining one, it happened quickly, but for random forest SVM, it took time. Then it done with the perform logistic, decision tree, KNN, and Gaussian naive Bayes. So we can see the accuracy for the best accuracy which we got is for 82, 89, 81, 85. So random forest is the one which is giving us the highest accuracy. So let's perform the hyperparameter tuning on this random forest. So perform forest classifier. So it created 3 parameters: n estimator, depth, and features. Let's see how it will give us the results. Let's run it. Now here, let's understand this code also. So what we are doing is we are applying the random forest, all the parameters, and CV refers to cross validation with the set size of 5. So it is performing 5 iteration for each of every iteration. So the total iteration which it's going to follow is going to be 3 times 5 times 5 times 5. So that is the number of models it is going to generate using the grid search CV. Let's see the final results. It is going to take few minutes. So finally, the code has been executed, and we can see based on the grid search CV and the randomized search CV, we got the output as 86%, which was originally somewhere around 82%. So by performing the hyperparameter tuning, we are able to get more enhanced model itself. Now, as we have the better model, now let's finally save it as a deployable file. So save model for deployment purpose. So you can see that's how you can just finally save the model file. And if you check out over here, you can download this model file, which you can install it or which you can use it for the deployment purpose. As we can see, now we are able to achieve the full-fledged coding practice for the data science project in less than 30 minutes. That is the use of this generator or generative AI code from this Colab. That is all we have to cover about this Colab's new product. And in the upcoming videos of this series, we'll be talking about some new, more interesting facts about some AI tools which can increase your productivity even higher. So stay tuned. That's all. Thank you.